All right, so now we're looking at number 2 on 2.7. This is the second page. And we're given a congruency statement. This is the first time we're given a congruency statement. So segment AB with a line over it is congruent to segment CD with a line over it. Right? We're trying to prove CD is congruent to AB, or line segment CD is congruent to line segment AB. So we start with our given, of course. So we're going to write AB with a line over it, congruent to CD with a line over it. That's given. Okay? And what is our methodology on how to write a proof? Well, we start here, right? Of course, step 1, write the T-chart, statements, reasons, number our rows, right? Write the given, write given. Okay, so let's ignore step 1 and 2. But step 3 is our first real step. It's turn any congruency statements into equations using definition of congruence. Okay, and that's what we're going to do here. We are going to turn this congruency statement that they've given us into an equation using definition of congruence. Right? And how do we do that? Measure AB is equal to measure CD. That's how we do it. You just take the congruency statement, turn it into an equation. You take away the line over the line segments, because now we're talking about measure and measure, number and number. Right? And so from there, we're trying to prove CD is equal to AB. So what we need to do here on statement B is we need to flip it. We need the CD on the left side and the AB on the right side, right? And so what property allows us to do that? Well, if we're looking here, it is not reflexive, right? That's a common mistake. Reflexive is same equals same. And we're not going to be using reflexive until a couple of chapters down. It is symmetric, right? Symmetric lets you flip an equation. And so that's what we're going to be using here. So it's going to be symmetric property. Okay. And then now we need to go ahead and turn this equation back into a congruency statement. You see this? Our proof is a congruency statement. So how do we do that? Well, we just say line segment CD congruent to line segment AB, like so. And our reason is definition of congruent segments. You see, definition of congruence segments, right? It lets you go from congruency statement to equation, but it also lets you go from equation back to congruency statement. Definitions let you go both ways. Okay, it's if and only if. So anyhow, we can go from this equation back to congruency statement if we need to, using definition of congruent segments.